So today we solve top 10 numerical on electric charge and field. Okay. So class 12 physics first chapter. Here we solve the top 10 numerical for important in board exam. Okay. Not JEE or Neet exam. That in for board exam only. Okay. If you solve these numerical, I think there is enough. Okay. Actually, not means enough if you solve these type of numerical if you get in board exam. So here we can solve the first numerical. The Coulomb's law and application. Here the two charges plus 3 microcoulomb and minus 2 microcoulomb are placed 30 centimeter apart in air. Calculate the force between them where K value is given. So and actually you know that that is plus 3 microcoulomb. The separation is here 30 centimeter and here is a minus 2 microcoulomb. Okay, so coulomb is SI unit. So now we convert 30 centimeter and convert into SI, that is 0.3 meter. And you know the formula is F equal to K value is given. And what is the K? Electrostatic force constant or Coulomb's constant. If you say any name, 4 pi epsilon naught, the value is given here. Okay, so K magnitude of Q1 and Q2 over their separation square, and know that K value is 9 into 10 to the power 9. So Q1 Q2, so 3 microcoulomb, 3 into 10 to the power minus 6, and here is magnitude only 2 into 10 to the power minus 6, and the separation is 0.3 square. So 9 into 10 to the power 9. So 3 to the 6 into 10 to the power minus 12. So minus 3 square is minus 0.3 the 9.09. Point remove times 100 here. So cancel 9, cancel these two, and otherwise you get 6 into 9 plus 2 11, 10 to the power 11, 10 to the power minus 12. So you get is 6 into 10 to the power minus 1 and Newton. And direct and easy question. Okay, that is just application of Coulomb's law. Next numerical is a net charge on electrostatic force on a charge. So 3-point charge plus Q minus Q and plus 2Q are placed at the corner of an equilateral triangle whose side is 10 centimeter. So first we need a triangle. Okay. So here are the three charges. So plus Q here. So another charge is minus Q at 3 corners, and here is plus 2Q. And given is equilateral triangle of side 10 centimeter. Okay. So 10 centimeter means 0.1 meter. 1 meter. So calculate net force on 2Q. That's very important. Net force on 2Q. Here you see the diagram first. So that is a minus Q, that is a plus Q charge. Both are in plus and minus. Okay, so there is an attractive force. So force in that direction. I name that force is F minus due to that name for minus charge. That is K, magnitude of these two, 2Q times Q, that is a 2Q square, and their separation is a 0.1. 0.1 whole square. Okay, and other is a plus Q and that is a plus 2Q. Both there is a repulsive force in that direction. That is F plus, we get some K, magnitude only these two forces, so 2Q square, and their separation is 0.1 whole square. Now from vector algebra, we know that resulting force in that direction. Now If you want to solve the equilateral triangle, this angle is 60, this angle is 60, this angle be the 60, all the same angle. Okay. Now, if we try to solve these, if I draw a parallel of this f plus vector in here, that is f plus. Okay. So that is f minus that f plus. Okay. So this angle be the 60 and this angle will also be the 60, because this line and this line are parallel, these are the sectors, so these two are alternate angle. Okay, from alternate angle concept, we solve this. And from vector algebra, we know that resulting force that is equal to root over of f plus square a square plus f minus another vector square plus twice of these two vectors f plus multiplied by f minus cos of angle between these two vectors is 60 degree. So f plus and f minus, their magnitude be the same. Magnitude be the same. So if it is to just because only added, okay. So twice f plus square means k square. 2 square with a 4 q to the power 2 square with a 4 over 0.1 whole to the power 2 square is 4. Here, these multiplication of these two, similar the k square, and that is 2 and 2 we get 4 q to the power 4 1.1 whole to the power 4 and cos 60, that is opposite of sine, same as sine 30, that is 1 by 2. Okay, so cancel these two. Now we can take common of k square times 4 q to the power 4 over 0.1 whole to the power 4 times 2 plus 1 root. Take some extra, okay. Pages from taken here. So k square and these two outside the root is k twice q square, that is 0.1 whole square, that is root 3. And we know the k value is 9 into 10 to the power 9 and 2k square. 0.1 square means 0.01. I get some root 3. If I remove this point times 100, so ignore this. So 9 root 3 10 to the power here, not Coulomb, is not given actually, charges value. 9, 10, 9, 10 to the power 9 or 2. So 18. 9 into 2, 18. 18 root 3, 10 to the power, get 9 plus 2, 11. Q square, force is a Newton. If you used to solve that, we know the root 3 value is that is 1.732. So if you want to calculate, just 1.732, okay, put the here. Okay, and you get the result. Okay, that is very important, how to solve that type of numerical. Next we solve number 3. So calculate the electric field intensity at a point 50 centimeter away from the charge. Charge is given, suppose plus charge 5 into 10 to the power minus 6. So here is the 50 centimeter means 0.15 meter. Calculate the electric field at that field. So here just calculate only the magnitude. So kq over r square. K we know that 9 into 10 to the power 9. Q value is given here 5 into 10 to the power minus 6. and here r square is 0.15 whole square. No, just calculation here. So 9 into 10 to the power 9 times 5 into 10 to the power minus 6. So that is equal to 9 into 0.15 whole square, get with 15 square is 225, and after point that is 2 digits, so their square is 4 digits. So this. Now if you remove the point, 40, another 0, 40, and 5 4 22 5. So 5. So 9 also get 5. So if you solve this, suppose 5 to the 10, 2. So 2, 9, 10, 11, 12. 2 into 10 to the power 12 into 10 to the power minus 6. And you get 2 into 10 to the power 6. 12 minus 6 is 6. Newton per Coulomb. And you know that how to solve this. Okay. Very easy. And number 4. Electric field on the axis of a ring. Okay. The ring of radius 10 centimeter carries a uniformly distributed on charge 2 into 10 to the power minus 6 Coulomb. Calculate electric field at a point on the axis of the ring at distance 5 centimeter its center. Okay. So we need a ring. Okay. So here to solve we need a ring. That's a ring. Okay. Ring, that is center point. So ring of radius is 10 centimeter. So radius is 10 centimeter. Ring radius from center, and the charge is 2 into 10 to the power minus 6 Coulomb. Calculate the electric field on the point on the axis of the ring 5 centimeter from the center. So here 5 centimeter from the center, like here. The distance is 5 centimeter means 0.05 meter. The distance is that. Calculate electric field here. Okay. And the ring from this distance, sorry. Okay. That is that here the distance is called R. That is 10 centimeter, that is 5 centimeter. So electric field at that point E, that is equal to some value of K here in that direction, obviously. That is not an axis. So here E vector here, and in that direction that angle be the theta. The angle be the theta, that is a E cos theta. Okay. So K, so that is solved this. Okay. This angle be theta, this angle theta K. So Q given 2 into 10 to the power minus 6 over the distance from here to there. That distance is there, that is R. The distance now given is R. So that is a right angle triangle, and R is the hypotenuse, that is the base, and that is perpendicular. So 10 square, 10 centimeter actually, sorry. Okay, now convert into meter, not 10 square, that is convert into meter. So 0.1 meter square plus these 0.05, okay, whole square, and these get a root and they are square, so root and square will cancel, and the distance is cos theta, okay, and you know the value of k, 9 into 10 to the power 9, 2 into 10 to the power minus 6, so minus 1 square we get 0.01, and here we get 0.0025, okay, and the cos theta, so cos theta, that is a base, that is hypotenuse, okay, base and hypotenuse here, okay, so cos theta, that is base, 0.05 over hypotenuse r. So you also get the distance r, so 0.05, and the r here you get r. These are similarly we solve these, 9 into 10 to the power 9, 2 times 10 to the power minus 6. If I added these two, okay, so 0.05, so times 0.05, I added these two, we get suppose 0.0100 and 0.0025, and we get 0.125. So same value here, but here is the root, okay, so 0.0125, here we get same 0.0125, but there is a half, so that is 9 into 10 to the power 9 times 2 into 10 to the power minus 6, that is 0.05 over there to the power 1. So added these two, 0.0125, 1 plus half, we get 3 over 2. Okay, now you can solve these. Okay, so if you wish to solve that, that is okay. So otherwise you can do it with calculator and get the result. Okay, so it actually take a time. 9 to the 18, and here to the 18, 10 to the power 3, so 0.05, so root over of 0.0125, their whole cube, okay, and if you their whole cube, the get result is, I solve this with calculator and get result 0.014 times 0.0014. Solve these, and if you multiply these, you get a result, okay, and get magnitude here, that is a Newton per Coulomb. That is a homework actually, okay. You solve these and put in comment section. So we jump into the next numerical, number 5. Torque on an electric dipole. Very easy numerical. How to solve the torque on electric dipole? So torque tau, dipole, the charge is given there. The separation is 6 centimeter from the place in the uniform electric field. The magnitude is 4 cross 10 to the power 5 Newton per Coulomb. Calculate torque experienced by the dipole when the angle between dipole axis and the field is 30 degrees. So tau equal to, that is P E sin theta. Okay, and tau equal to, know that P cross E, so P cross E is a sin theta. So now very easy, the P is a charge time their separation. Okay, The charge any magnitude only 2 into 10 to the power minus 8, and the separation is 6 centimeter. Okay, separation is a 6 centimeter. So convert centimeter to meter. Geez, that is get value of P. And here the electric field is 4 into 10 to the power 5 and sine 30 degree. Okay, now to solve this. 6 to the 12, 12 for the 48 and 10 to the power 8, and these two 0 cancel, that is 3, 10 to the power 5, 8 minus 5 into sine 30, that is half, this cancel, that is 24, 24 into 10 to the power minus 5, unit is torque. Okay, know the P, SI unit of P, dipole moment. Okay, that is charge into distance. So meter times Coulomb or Coulomb's meter, and the electric field that is equal to Newton per Coulomb. So Coulomb cancel, final unit is Newton meter. Okay. Now jump to the next numerical, number 6 numerical. Very easy numerical. Calculate the electric field at a 10 centimeter away from the center of a dipole on the axis line. Dipole has a charge of 1 microcoulomb. Separation is 2 centimeter. So we know the formula actually. Okay, there is a derivation and we know the formula. Just put the value. Field a point. So that calculate electric field E. Okay, that is we know that 2p dipole moment 2p over 4 pi epsilon naught r cube, separation to the cube. Okay, so 1 over 4 pi epsilon naught, we know that 9 into 10 to the power 9, 2p. P we need just only dipole moment, charge 1 microcoulomb. So 1 microcoulomb here. So 2 here is 1 microcoulomb means 1 into 10 to the power minus these two, actually 10 to the power minus 6. Okay, the 10 centimeter away from the center and separation is 2 centimeter. Actually the look like diagram, see the diagram is plus q and there is a minus q. Separation between these two is that 2 centimeter, that is the dipole center, and the dipole moment P, we know that minus to plus direction, and electric field 10 centimeter away from the center. So electric field actually here, okay, and the distance is 10 centimeter. Okay, that's the calculate electric here. So that is P, okay, that is charge and distance is these two, the 2 centimeter means 0.02 meter. Okay, over 4 pi epsilon put value here, r cube, r is the 10 centimeter here actually, that's the r. R is the 10 centimeter means 0.1 whole cube. So 9 to the 8, remove these 2 times 100, 2 to the 4, 9 for the 36, and 10 to the power here we get 3. 9 minus 6 is get 3. So 0.30, 0.001, these 2 times makes 100 or so cancel these 2. 36 into 10 to the power 6. Okay, electric field unit is Newton per Coulomb. The mistake. Oh, sorry. 3 and 2, 5, not 6. Okay. 3 plus 2, 5. Okay, this is the answer. Number 7 numerical, electric potential energy between two charges. So we know that the potential, that is U, that is Q1 Q2 over 4 pi epsilon naught times separation between two charges R, and we know that 1 over 4 pi epsilon naught is 9 into 10 to the power 9, the two charges. So given is 2 2 into 10 to the power minus 6, so minus 3 here into 10 to the power minus 6 also. The R separation is 50 centimeter, now convert into meter, that is 0.5 meter. Remove these two, get 10, 5 to the 10, so 9 to the 18, 18 to the 54, 54 to the 108 minus. So 9 here minus 12. So minus 12 or 9 get 10 to the power minus 3. Okay. So that the energy means joules. Okay. Very easy numerical actually. And number 8. First you know the formula. Okay. Basic equation and formula. Then try to draw a diagram. And if you know the diagram, how to draw a diagram and know the formula, then the 80% is done. Okay, and now the 20% is the calculation. In a physics exam, the main is the how to approach, and the examiner see that if you know the perfectly approach, write the perfect formula, then you get 90% marks. Okay, 90%. If you have the 10 marks in that question, if you perfectly put the formula and the data, approach is correct, all is okay, but there is some calculation error maybe, so you get 8 to 9. Okay, 80 to 90% you get. Okay, so that's why the physics here is very important, how to approach. Okay, your approach be the perfect and diagram be the perfect, and you know the formula is perfectly and put the all data perfectly, then the calculation is not important here actually. Okay, now question number 8, the charge distribution on the conductor. The conducting sphere of radius 10 centimeter is a given charge 5 into 10 to the power 6. Find the surface charge density on the sphere. Okay, very easy question. That sigma, that is charge over area. Surface charge means get a area. So charge is given 5 into 10 to the power minus 6. So area 10 centimeter and sphere, the area of given, the area of surface area of sphere is 4 pi r square. So 4 pi 10 centimeter means 0.1 meter square, and solve this. Okay, 5 4 into 3.14. So 0.1 square means 0.01 into 10 to the power minus 6. So remove these two, get 100. Okay, now very easy. Okay, and that's the homework. You solve this and take a picture and put in comment section. Okay, that's the homework. The unit is important, is charge, coulomb, area, meter square. Coulombs per meter square. That's the SI unit of the sigma. Okay, that now be the next numerical. Is number 9. Force in a vector form. Vector form. The two charges plus 3 microcoulomb and minus 4 microcoulomb are located at a point 0, 0, 0 and B 0, 3, 4 respectively. Find the force on minus 4 microcoulomb in a charge in vector form. Okay, so here we need a XYZ direction. Okay, now that is called okay. Suppose say that x, say that y, and say that z. Okay, so x, y, z, that is say that plus minus. Okay, now here that plus 3 microcoulomb present in A 0, 0, 0. So that origin point 0, 0, 0. Okay, so that is actually minus x. Okay, so x, y, and say the z. Okay, that is a minus z. 0, 0, 0. So here the plus 3 coulomb here. Plus 3 microcoulomb 10 to the power minus 6 at that origin point 0, 0, 0. And another charge, that is point A, B 0, 3, 4, 0, y axis be the 3, 0, 3, and get 4. Suppose get here the point B. Okay, actually that's not a x axis. Okay, that is actually from here. That is a 3, that is 4, that is a 0, 3, 4 point. Okay, now the resultant to the another curve, the resultant is that. Okay, here I have an arrow. Okay, that's the resultant. Okay, now calculate the force, and that is one. Calculate that my B. Force on minus 4 microcoulomb. Okay, minus 4 means here. That is a minus 4 microcoulomb. So here the force in that direction, obviously. Force in that direction. So the force F. Okay. So see that to calculate the force. Okay. So that is a K, Q1, Q2, the magnitude of these two. 3 microcoulomb 10 to the power minus 6 times 4 into 10 to the power minus 6. Okay, so now the separation between these two, okay, if you see the diagram very carefully, okay, the distance is from 3 and that distance 4 and that is 90 degree. So separation from here to there, 3, 4, base is 3, perpendicular is 4, so hypotenuse will be the 5. Okay, otherwise you can solve this. Okay, 3, 4. So we know that that is R, that suppose called delta R. So root over of 0 square, we know that from vector algebra, 3 square plus 4 square. Otherwise you get the right angle triangle formula. Pythagoras theorem apply, you also get a 3 square plus 4 square root over, that is a hypotenuse. That is you get 3 square 9 plus 16 root over 25, you get 5. The separation is 5 square. Now the very important is the magnitude in the direction. Okay. So see the diagram very carefully, that the direction. Okay. So how to define the direction? So that is a vector. A vector defined as the magnitude of a vector, like unit vector, that is defined as direction. Now define unit vector, you get a vector over their magnitude of a vector. So see that a vector is a gap between these two, 0 minus 0, resultant vector, 0 minus 0, it's 0. So 0 I cap, that is 3 minus 0, that is a 3 j cap, plus 4 minus 0, 4 k cap, we solve in vector algebra, okay, by their magnitude. Magnitude is a 5. So get 3 by 5 I cap, 4 by 5 j cap. So direction is that you get 3 upon 5 I cap, 4 upon 5 j cap. Okay, we know that j cap, the direction. And know the k value 9 into 10 to the power 9 and solve this. Okay, so 3 4 the 12, 10 to the power minus 12, 5 square be the 25. So 3 upon 5 means 0.6 divided by, okay, that is j cap, okay, not I cap, sorry, that is j cap plus 4 upon 5, we get 840 by 5, that is get 8.8, that is k cap, sorry, that is k cap. Okay, so 9 12 the 108, and here you get 10 to the power minus 3 upon 25. So 0.6 j cap plus 0.8 k cap direction. So now very easily to get skip that part. Okay. So if you solve these, okay, so that is if you divide into with the help of calculator 108 by 25, you get 4.32. Okay, 4.32. So okay, so times 10 to the power minus 3, that is 0.6 j cap plus 0.8 k cap. Now that 4.32 times 0.6 into 10 to the power minus 3 j cap plus 4.32 times 0.8 10 to the power minus 3 k cap. That's the answer. And now we solve this multiplication, that is homework. Okay, solve that equation, take a picture and put in comment section. Okay, that's the homework. Number 10, electric flux through a surface. Okay. Electric flux through a surface. A point charge 1 microcoulomb placed at center of the cube. The side is 20 centimeter. What is the net flux through the surface of the cube? Okay, the Gaussian surface. Okay, and you know that phi flux, that is from Gauss's law, charge q over epsilon naught. So q1 into 10 to the power minus 6, and the epsilon naught is 8.854 into 10 to the power minus 12. You know that. And okay, that is okay. Tell me, calculate. So 20 centimeter not needed here. So solve these two. So if you solve with the help of calculator, and I put the numerator, SI unit here. Okay, so if you help a calculator, you get a result 1.1 approximate value actually into 10 to the power 5. So phi equal to E, Newton per Coulomb time meter square. That is E into A. A means area. Newton Coulomb to the power minus 1 meter square. Okay. That's a 10 numerical, very important in board exam. Okay. If you any doubt in that 10 numerical or any other numerical, well, so always welcome in comment section. So today in the class here. Thank you.